Okay, we're looking at problem 2, using factoring to multiply rational expressions. So first let's read this. It says, as problem 1 indicates, products of rational expressions may have excluded values. For the rest of this chapter, it is not necessary to state excluded values unless you are asked. So sometimes the product of AC over BD of two rational expressions may not be in simplified form. You may need to divide out common factors. So just like you would when you're multiplying fractions, you can apply that same concept to multiplying rational expressions. So let's take a look at the example problem. And I want to write it on the board. So I have x plus 5 over 7x minus 21 times 14x over x squared plus 3x minus 10. Now, first thing that I would like to do is I would like to factor. So the first one I can't factor. It's going to stay the same, so I have x plus 5. The bottom one I can factor out of 7, and I get x minus 3. The top one I can factor out of 7 times 2 times x. And then the bottom one I can do x plus 5 times x minus 2. So one thing a lot of students ask me about is how do I know which ones I can look at? So I have to look at my crosses and see what I can cross out. So notice that I have this x plus 5. X plus 5 is connected to each other because of that plus sign. So I have to have another x plus 5, and I do. If I look here, I have a 7, looking at my crosses this way. I have a 7 and I have a 7 here. They're not connected by anything, so I can cross those out. Now I can't cross out this x with this x because this x is connected to this x minus 3. So there's nothing alike. So my final solution when I multiply everything across, I'm left with just 2x at the top and x minus 3 times x minus 2 in my denominator. And that's the same thing they got here. So now let's look at the got it. We have 3x squared over x plus 2 times x squared plus 3x plus 2 over x. So again, I factor. Top is 3 times x over x plus 2. Oops. Times x plus 1 times x plus 2 all over x. And so my x here and here are not connected to anything. My x plus 2 is connected to each other, so I have a 1 on top and bottom. Then I multiply straight across. I get 3x times x plus 1. There's nothing left in my denominator except an invisible 1, so there's an invisible 1. And I don't have to put it over 1. I can leave it just like that. The last one, it says in problem 2, suppose you multiply the numerators and denominators before you factor. Will you still get the same product? You absolutely will, because after you multiply straight across, then you can reduce out any common factors. So it's a preference which way you would like to do it. I hope this helps.